So I will present the techno-economic analysis by comparing cost estimation of shared anchored and unshared anchors. So first I will go through the main findings and challenges that have been identified in the literature. Then I will go through some cost functions that we have estimated during these studies, and then there will be the case of application with some case studies that are based on the first cases that Tanguy presented previously, and then some general conclusions. So you can go to the next slide. So first, for the main findings and challenges identified in the literature. So what we found is that first, there can be only pile or section piles that can be used as shared anchor, as there is a multi-directional loading. The anchor position is imposed in shared configuration, so it may increase line length compared to unshared configuration. The number of anchors are reduced. The installation, inspection, maintenance, and decommissioning are positively impacted. However, for the mooring or a floating offshore wind failure, it will have more consequences on shared anchor, as the failure could impact several floating offshore wind linked to the same anchor. And the risk is increased in case of failure, thus the frequency of inspection should be increased. So some of these assumptions were considered in the cost analysis. So first I will go into some cost function. So first, for the procurement cost, we consider for the mooring line cost some basic linear function based on the MBL of the mooring line. So here you can see the cost function that we consider for different type of mooring line. So what we can see is that for chain is much costlier than, for example, polyester or nylon that are cost effective. For the anchors, we also consider cost of anchor, but linear function for cost of anchor, but depending on the weight and not on the MPL. And for the anchor, we perform some preliminary pre-designed based on the ABS standard in order to perform the comparison. And as there are no really norms for some preliminary design for shared anchor, we use the same design as for non-shared anchors, and we added a safety factor for the shared anchor of 1.2 to consider the highest higher difficulty for the shared anchor procurement. So what we can see is that for the cost, we can see that the drag anchor is higher than for example, the pile anchor or the shared pile anchor. So yeah, you can go to the next slide. Then we will go through the installation cost functions. So that are divided into shared and unshared anchor cost. For the installations, there are various parameters that should be taken into account. So first, there is mobilization and demobilization of the vessel. So that is constant and independent, and the same for each cases. Then there is a geotechnical investigation cost. So it is the same cost, but it will be dependent on the number of anchors. So it will reduce for shared anchor, as there is less anchors than compared to unshared anchor. Then there is a cost linked to the vessel cost and the installation time of anchor. So the installation time will be dependent of the anchor type, and everything will be linked to the number of anchor. We added an additional percentage, an additional cost to take into account weather window, transit, etc. that is not taken into account in this cost function. So that's why there is some additional percentage that is taken into account. And there is also the installation time of the mooring line that is also dependent, so the number of lines. and that is not varied between shared and unshared anchor, and as there is the same number of mooring line. For different anchor types, so what will change will be the installation time, but also for some cases, for example, as suction pad or driven pad, there are some additional costs that should be added. For example, for suction pad, there is a need of ROV for installation of anchor, and for the driven pile, there is a need of a barge for the transport of the pile, for example. And for the shared anchor, what we consider is that we consider also an additional percentage, as we will foresee that the cost for shared anchor, it will be more difficult, more complex, so there will be an additional cost to the installation of shared anchors. So I put in the below in the slide the different installation times, so we can see that there is a high variation between the installation type between the different anchor types. You can go to the next slide, please. Then we will go through the operation and maintenance cost, and first we will go through the inspection cost. So the inspection cost, it will be independent of we will consider it independent of the type of anchor and mooring lines, and will only be dependent of the frequency of inspection of each anchor, the frequency of inspection of each mooring line, so the cost of vessel, so the lifetime, of course, and the number of anchors and mooring lines. So that will be the only difference will come from the number of anchor between shared and unshared anchors. So you can go to the next slide, please. So for the repair and replacement cost, I will go first through the repair cost of the line and anchor. So it will be the same formulation for line and anchors. So it will be dependent on so first there will be the mobilization of the vessel that should be done each time. So then there is the vessel cost with the time of repair combined with the failure rate and the lifetime of the floating wind turbine. And there will be also a repair cost that will be considered for anchor and mooring line. It will not be the same repair cost, but it's considered the same for each, the same between each anchor and each mooring line. For the replacement cost, for the replacement cost, for the unshared anchors, basically it will be based on a replacement rate that is taken into account, and for the anchor, so we will consider also the installation time of the anchor, the dismantlement time, and the installation time of the line. And it will also be dependent on the cost of the anchor. So the replacement cost will be anchor type dependent, and also dependent on the number of anchors. And for the shared anchor, it will be the same formula, except that there will be, as for the installation cost, an additional percentage that is added for the vessel installation based on the difficulty to install anchor, shared anchors. So you can go to the next slide. So first, we will go through then the case studies. So based on the cost function that I described before. So there will be 3 case studies studied here. So first, for a water depth of 80 meters with a catenary mooring line with chain only. Then for a water depth of 80 meters with catenary mooring line and chain plus nylon. And we will here what we can see is that on the case 2, the radius of the mooring line is not the same between mutualized and non-mutualized anchor. We can see that for non-mutualized case, the radius of the anchor is of the mooring line is reduced, and so there is less line length. And for the case 3, we consider the water depth of 600 meters with taut and polyester. Yeah, can go to the next slide. So first we go through the case 1. So for the case 1, so in 80-meter water depth with chain catenary. So what we can see between the variation of shared and unshared cases. So first, we consider driven piles for the shared mooring lines and the unshared mooring lines. And for the unshared cases, we also consider drag anchors to compare, to see also the comparison between drag anchors and driven pile shared anchors. So what is observed is that there is no difference for the line length and MBL, as it is the same mooring system that is used for shared and unshared mooring lines. So there is no variation in that. There is only the number of anchors that is changing, and the ultimate holding capacity that is slightly changing, but it is a small variation. You can go to the next slide, please. So first, we will only compare the case with hammer installation. So what is observed is that the procurement cost is reduced by 7% approximately. The installation cost is reduced also with a smaller reduction for drag anchor as it is easier to install. And the overall, so global procurement and installation cost is reduced of approximately 12%. There is few variation between pile and drag embedded anchor, as it is 12 for pile anchor and 10% for drag anchor. The maintenance cost reduction is reduced of 23% for both cases. There is really no variation between pile and drag anchor. And the overall cost reduction is reduced of 16%, 68% for driven pile and 16% for drag anchor. So we can see a high cost reduction between shared anchor and unshared anchor. When we look at the ratio between the different, the total cost and between procurement, installation, and maintenance, what we can see is that for shared mooring lines, the maintenance cost ratio is reduced. The installation cost ratio is reduced. However, the procurement cost ratio is increased. And what is observed is that the procurement cost is governed by the mooring lines. Yeah, can go to the next slide. Then there will be a small slide on the safety factor for the shared anchor cost. So as a base case, as I said earlier, I considered a safety factor of 1.2 for shared mooring lines, and I did a sensitivity by considering a safety factor of 1, so no safety factor at all. And that leads to almost no reduction, a few influence on the procurement reduction, and the global cost reduction is only reduced of 0.5%. So what we can see that when anchor procurement costs tends to be negligible compared to others, the safety factor applied on anchor design have a limited impact on global costs. Can you go to the next slide, please? Then for the case 2, so for the case with a chain plus nylon in 80-meter water depth. So here we compared driven pile with drag anchor, as we saw that drag is slightly cost-effective, more cost-effective compared to driven pile in unshared configuration. And here what we can see is that the line length, there is a variation between shared and unshared anchor, with a smaller line length for unshared mooring lines, and a higher MBL, a smaller MBL for unshared mooring lines. So it leads to a procurement cost that is increased for shared anchor as the mooring line length is increased. So the same installation cost reduction is observed as in case 1, and the overall procurement and installation cost is slightly reduced, only of 3% in case. There is approximately the same maintenance cost reduction around 25%, leading to an overall total cost reduction around 90%, with operation and maintenance being the main contributor. So here what we can see, so I also did the cost ratio between maintenance, installation, and procurement. And here what is observed is that this maintenance cost that is the driver of the total cost. And the maintenance cost ratio is reduced. The installation cost ratio is reduced also, but the procurement cost ratio increases. And the procurement cost is still governed by the mowing line cost, as in the previous cases. And yeah, we see that the maintenance ratio has increased compared to the other case with full chain configuration. For the case 3, so with the case that taught polyester in 600 meter water depth. So here we compare driven pile shared and driven pile unshared. So what we can see is that the variation of line length and variation of MPL, but it still leads to a procurement cost reduction of 14%. The installation cost is also reduced as observed in the first case. It is the same reduction. And the overall procurement and installation cost is reduced of 28%. What we can see is that the maintenance cost reduction is around 28%, and the overall total cost reduction is also around 28%, with O&M being the main contributor, as we can see on the graph below. Yeah. And here we can see that the mowing line, the anchor mowing line is still the main contributor for the procurement cost, but with anchor being having a slightly higher percentage compared to the other cases, but only of 9% of the total cost, total procurement cost. Sorry. And then we also perform a comparison with a suction pile. So here we can see a high cost reduction for the suction pile of 37%, as the cost of the size of the suction pile is much more important than the size of the driven pile. That leads to a higher reduction where there is less anchors. So the installation cost reduction is similar to the comparison between two driven piles, so there is no variation. And the maintenance cost reduction is of 30% due to the anchor pricing that has an impact on the maintenance cost. And the overall total cost reduction is of 33%. So it can be seen that the anchor cost is a crucial factor in reducing overall expenses. And here we can see that, for example, that for the procurement cost, the anchor cost is a huge part of the procurement cost, with 32% of procurement cost being from anchor compared to mowing line, compared to the other cases. So for the general conclusions, what we can see is that shared anchors are cost-effective compared to drag anchor, that are themselves cost-effective compared to driven piles. The main cost reduction are obtained for installation and maintenance. The total cost main contributor is maintenance, especially. And a cost reduction between 16 to 33% are obtained for shared anchor. And it can be seen that suction pile leads to a higher cost reduction than driven pile. But it can be seen that it was suction pile compared only to suction pile. We didn't compare suction pile with driven pile. And some general conclusion and remarks. So it should be noted that the inspection rate for shell anchor could be increased while still achieving cost reduction, as inspection costs represent a small portion of our overall maintenance expenses. The replacement cost could be optimized by accounting for production loss of the floating offshore wind turbine during downtime, and this would help minimize difference between shared and unshared anchors, or as a shared anchor failure will impact 3 floating offshore wind turbines instead of 1, as I said in the introduction. And the maintenance costs are significantly influenced by the failure rate, which could be higher or lower than assumed in this study, impacting overall cost outcomes. So it should be noted that all the values that I said here are based on a certain failure rate, and it can be smaller depending on what you consider. And the knowledge transfer from geodesic studies need to be completed to refine the safety factor defined applied on the shared anchor costs.